Hi, you're back. In our last video we left off tellurium's configuration, and upon looking at it, it is quite lengthy. I mean, we're lucky we didn't do francium. It wouldn't have fit on the screen, right? So there must be a way that this can be shortened, and there's definitely a way to do that. Let's think about this a little bit. If we had another period 5 element like rubidium, that's the group 1 element in period 5. And let's write the configuration for it. So I'm going to start as usual with 1s2, 2s2, and this is our first 10 electrons. Another 10 electrons, another 10. But now I get to the 5th period, right? The n equals 5, and the s is only 1 right here. So right here is when we eventually see a difference between the orbitals, but before isn't all of this up to here exactly the same? How come? Well, the orbitals fill in the same order every time, so the lowest energy to the highest energy. So, I mean, there are some exceptions to everything, but generally speaking, this is the rule. So, it turns out that there is a way for us to abbreviate all of this previous configuration and only show what's important, the tail that's important, the tail that makes it different. Now, could we figure out what element could actually convey this configuration? Ending in 4p6, I would have to say that this is, looking at my periodic table, this would have to be a noble gas with a full shell. If I look back, if I backtrack and look at what is my prior noble gas, group 18 element, I have to say that this is exactly like krypton, isn't it? Element number 36. I have 10, 20, 30, 36 electrons. That makes a lot of sense. So instead of me writing that whole, same beginning for all these elements, I could actually say, hey, you know what? It's the same as krypton. Here it is, krypton. And I'm only going to be specific by adding the tail end, which it was what really describes how tellurium is really different from krypton. It's a krypton with all this tail right there, right? So here is tellurium. If we were to want to do the same thing for rubidium, same thing. Since it's the same period, this is still the same 36 electrons. And then you just need to show one more electron. Where is that? In 5s. And here's my little electron right there, an extra one. That's it. Way shorter than showing, the configuration as we had it before. And because we use noble gases as our base to write our configurations, this particular configuration is called a noble gas configuration. Right? A lot friendlier than writing the whole thing. But how about you practice and you do a configuration for, why don't we just go a little deeper on the table and do number 82, lead, element number 82. Go ahead and do the long one. You can do it. Go the whole way, the long way, and then do a noble gas and see how much better that feels. All right, I will see you in the classroom.